In this video, we'll be doing a demo that you can follow. We'll be using the following hardware: an NI9178 8-slot CDAC chassis, an NI9234 module for acceleration measurements, an NI9236 module for strain measurements, an NI9213 module for temperature measurements, and an NI9239 module for voltage measurements. I have plugged an ICP accelerometer into the 9234, a quarter bridge strain gauge into the 9236, a thermocouple into the 9213, and a light tachometer into the 9239. The NI9178 chassis is connected via USB to my computer. From the main page, click on the gear and select Configure. The first step we'll need to take is creating a new configuration file. Select File, New, and name the config file and save it. You'll also need to choose a project path. Select the folder icon, navigate to your desired folder, and choose Select Folder. You can also fill out the other information on this page for documentation purposes. Now we'll look at connecting the hardware to our test setup. Click on Hardware and then select Refresh. The hardware we have attached will show up on this page. Select Apply. The hardware will now appear in the configuration tree on the left. Select the Maximize button to show all hardware on the system if it's not already visible. Next, we'll create a channel. If your channels are not already maximized, please do so. We'll create an acceleration channel for the 9234 module. Right-click on Excel and select New Excel. Assign a name and make any changes you'd like to the rest of the boxes. I'll name this channel Excel1 and leave everything else at its default value. Once finished, select the Apply button. You may need to click outside of the text box for the Apply button to become selectable. Now to apply our new channel under the Hardware section, maximize the 9178 chassis and the 9234 module. Right-click on the first channel slot, AI0, hover over Select Channel, and choose Excel1. Upon repeating this process for the rest of the channel, the configuration page will look like this. As you can see, I have a Strain 1 channel in the 9236, a Temp 1 channel in the 9213, and a Light Tac channel in the 9239. Now that all channels have been created, we can create the DAC, or Data Acquisition Task. Choose DAC in the tree, and with Multi-DAC selected, choose Add DAC. The new Multi-DAC, by default titled My Multi-DAC, will appear in DAC under the tree. Click on the newly created DAC, and then select Create Task. Enter the task name you'd like to use, and then select Modify Channels. Here you can select whichever channels you'd like to be recorded for this task. We'll choose all of them for this task. Use the Shift key to select all of them and use the top arrow, or just use the Move All double arrow, and then press OK. Because of the sample rates associated with our modules, we're informed that the sample rate has been coerced. Select OK on this page and the DAC is complete. I also recommend selecting Preview Data on Save. Be sure to hit Apply after you make any changes. To run the DAC, right-click on My Multi-DAC and select Run Test. The page which first opens up is the real-time view screen, which shows the current values as they update. Switch to the Data View screen to create charts and graphs to monitor the data with. Right-click anywhere in the spreadsheet layout and hover over New. We'll select Waveform Chart to view the acceleration values. In the blank waveform chart that appears, right-click and select Configure. Choose the desired channel, Excel1 in this case, and hit OK. We'll also make a few other data views. A waveform graph, which will be for our strain measurement, and another waveform chart, which will be for our temperature measurement. These data views don't look so nice laid out randomly on the screen, so on the Multi-DAC screen, select Tile Windows, which should make your screen look a lot better. Another nice feature is that Multi-DAC saves your data views. If you close this DAC and then run the test again, your DAC will pull up all of the same data views. One more data view we may be interested in for this example is a digital TAC. On the data view screen, create a new digital TAC. Choose the Light TAC channel. Change any other values as required by your tachometer and select OK. When you are ready to start collecting data, choose Start Logging. Take data for as long as you need, and when you're finished, select Stop Logging. Save the file, and then Test View Plus will pull it up automatically. This happens because we selected Preview Data on Save. The graph which pulls up automatically is not particularly useful in this case, as all 4 values correspond to different types of measurements. Thus, close that graph and open a new time history graph. Click and drag the desired channel into the graph, and then repeat this for each of the 4 values. You can use the View buttons at the bottom of the screen to edit your view of the screen as necessary. You can also export the graph as a simplified image as you desire by right-clicking inside the graph. If you need further assistance, you can use the Help documentation button on the top right, or you can send your questions directly to our support team.